Okay, let's get right into it. Why do chemical bonds even form? I mean, why do atoms stick together at all? You probably learned a certain story back in chemistry class, but what if I told you the real reason is way simpler and honestly a lot cooler? Let's dig in.
So, let's start with what you probably remember. It's that classic story, right? The one about atoms wanting to be happy or stable. The goal, we were told, was to get a full outer shell of electrons, just like those cool, aloof, noble gases.
But this whole idea really hinges on one big question. Do atoms want things? I mean, we talk about them like they do, but is that actually what's going on here?
I'm sure that sounds familiar, right? The sodium atom wants to lose an electron. This little sentence is pretty much the core of the myth we're going to bust today. It's what we call anthropomorphism, giving human feelings to things that aren't human. But let's be real, an atom doesn't have desires. It doesn't want a single thing.
See, at the end of the day, atoms are just stuff. They're collections of particles, and they're just following the fundamental rules of physics. They don't have goals or ambitions. So the why behind what they do can't ever be because they want to do it.
Okay, so if we're not going to talk about wants, let's put this whole full shell idea to the test. I've got a little thought experiment for you that's actually pretty shocking.
All right, take a look at this. We've got three different versions of a sodium atom. On one hand, you've got the positive ion, Na+, which, has that full outer shell we always hear about. Then you've got the regular, neutral sodium atom. And just for kicks, there's even a negative ion that also has a full outer shell.
Okay, let's just focus on the first two for a second, the neutral atom and the positive ion. Now, based on everything we learned in school, that full shell rule, you'd bet on the sodium ion, Na+, being more stable, wouldn't you? Go on, make a call. Which one is it?
Well, get this. When a bunch of 15 and 16-year-olds were asked this exact question, a whopping 97% of them got it wrong. That's crazy, right? Almost everyone chose the ion with the full shell. It just goes to show you how deep this misunderstanding really is.
And here is the big reveal. The correct answer is the neutral sodium atom. That's the more stable one. And when you stop and think about it, it makes perfect sense. To pull an electron off a sodium atom, you have to put energy in, right? It takes work. And in physics, anything you've pumped energy into is at a higher energy state, which means it's less stable. That so-called full outer shell doesn't make the ion more stable on its own. Not at all.
So, if this whole quest for a full shell is a myth, then what's really going on? What's the actual reason that all of chemistry happens? What's the real driver here?
It turns out the whole thing boils down to one single, powerful, fundamental force. And the best part? You already get it. You've known it your whole life.
Electrostatics. That's the secret. That's the whole show. This one single force is the engine behind every chemical bond in the universe.
And electrostatics is just a sciencey way of saying opposites attract. Positive things and negative things pull toward each other. You've seen this a million times. Ever rub a balloon on your sweater and stick it to the wall? That's it. You were doing electrostatics. That simple attraction, that's the whole game.
Okay, so now that we have this new lens, this simple idea, let's look at the main types of chemical bonds again and see how everything just clicks into place.
Just look at these two side by side. On one side, you have an ionic bond, and on the other, a covalent bond. Now, they look kind of different, sure, but what's amazing is that they're both driven by the exact same thing.
Let's start with the ionic bond. We're taught that the electron transfer forms the bond, but that's not quite right. The bond isn't the transfer. The bond is the attraction that happens after the transfer. It's the simple pull between that new positive sodium ion and that new negative chloride ion. That force of attraction is the bond.
And what about covalent bonds? We say it's a shared pair of electrons. But again, that's not the full story. The bond itself is the electrostatic pull between the two positive nuclei and that shared pair of negative electrons hanging out in the middle. The electrons are like this negatively charged glue holding the two positive nuclei together. Simple as that.
And this simple rule works for everything, no matter how complicated it looks. I mean, look at a nitrogen molecule. It's got a super strong triple bond. But what is that? It's just the same electrostatic attraction, but stronger. You've got two positive nitrogen nuclei being pulled together by a whole bunch of negative electrons, 6 of them in the middle. It's the same principle, just more of it.
All right, so to really make this new, simpler way of thinking stick, we kind of have to unlearn some of the old, misleading phrases.
So here are 4 things you probably heard in chemistry class that you can now officially throw right in the trash.
Yeah, every single one of these is a little bit off. Noble gases aren't stable just because of a full shell. They're stable because it takes a ton of energy to mess with them. Atoms don't do things in order to get a certain structure. They don't have goals. A covalent bond isn't just shared electrons, and an ionic bond isn't just the transfer. The bond in both cases is the electrostatic attraction that results.
Look, if there's one single thing to take away from all this, it's this right here. Chemical bonding isn't some complicated quest for atoms to get the right number of electrons. It's just physics. It's the simple, unavoidable result of positive charges and negative charges being attracted to each other. That's it.
It's pretty amazing, right? Sometimes the biggest, most fundamental ideas in science are actually the simplest ones. It really makes you stop and wonder, doesn't it? What other big, complicated ideas out there are actually just hiding a simple truth?